What's going on? My name is Anastasio Dalde. This is SDG Labs, and I just screwed up that introduction. Alright dude, today we're going to cover polynomials. See all of these things right here? This, those are all polynomials. I think of them as really skinny parrots. That's a joke because I'm thinking of poly as in poly want a cracker, nomials as in no food. Alright, anyway, let's check this out. I want to show you guys some interesting things about these polynomials. You're actually familiar with how to graph this one right here, 2x plus 6. That is a y equals mx plus b kind of thing. You've learned that in Algebra 1, where you're graphing a line. Same with over here, negative 3x plus 3, you're also graphing a line of mx plus b over here and over here. These are all the same type. They belong to the same family. So we know that all of these graphs are lines. Now, be it that this line is actually sloping up, and it starts at 6, whereas this line slopes down and it starts at 3, and so on and so forth. They're different kinds of, or they're different looking lines, but they're all lines nonetheless. This one right here, you're also very familiar with. This is a parabola. Now, what can I tell you about the parabola based off of what I'm looking at here? This 2 tells me that that parabola is opening up. It's a happy parabola, and this negative 6 tells me that it has actually shifted down. So the graph is probably going to look something like this. Opening up, shifted down. This 3 right here, it does something a little bit funky. What it actually does is it kind of moves it to the right and left, but it doesn't move it exactly perfectly nicely. So I'm going to guess that the graph is going to look something like this. Wait. I know that the y value that it has to cross at is negative 6. So I would say that the graph looks something like this. Or it could look something like that. I shifted it a little bit to the right, but I could have shifted to the left, and I think that probably would have been. Either one is true. I'm not sure whether or not that moves to the right or left. Anyway, we know that this is a parabola. That's really the important thing. Right here, this is called a, I'm actually not sure what that's called. I just call that the to the 4th degree, I guess. And then this is a function that's to the 6th degree. I think that after a parabola, they don't give them special names anymore. No, wait, I messed up. That's actually after, if it's to the 3rd power, that's a special name called a cubic function. Anyway, what I want to be able to show you is identify parts of this parabola. We don't actually write this in there, but there's you can actually put a 1 out off top over there, because x is the same as x to the 1st power. All right? Now, we say that this polynomial is actually to the 1st power, because the highest exponent on the x variable is 1 in this case. Now over here you have an x squared and you have an x to the 1st power term. But the highest of the exponents is the 2. So we call this a polynomial to the 2nd degree. This is actually to the 1st degree, this is to the 2nd degree. This would be x to the 6th degree, so this whole polynomial is known as a 6th degree polynomial. Now the numbers out in front are called coefficients. So every time you see a number over here, those are all just called coefficients. They're just numbers that you put out in front of variables. If I'm asking for the leading coefficient, that's saying, well, what is the number in front of the exponent, or of the variable with the highest exponent? So that would be, for this one it would be 2. For this one it would be negative 6. For this right here it would be 0. I got you there. Even though there's nothing there, you can kind of think of it as a 1 in front. If there were 0 out in front, it would be 0 times x squared, and that would just be 0, so you wouldn't even have the x squared term, and then you would just have x to the 5th power. Does that mean that this is not a coefficient? No, that's not true. These guys after are coefficients. They're just not a part of the leading coefficients. Shoots, bro. Up out.